Alrighty, good morning everybody and welcome to the wolfSSL live webinar on testing cURL for security, presented by cURL author and maintainer Daniel Steinberg. My name is Kajal Subkota and I will be moderating this webinar. All attendees will be in listen-only mode. If you have any questions, please use the Q&A box or raise your hand to be unmuted if you would like to ask the question live, as we will host a Q&A session following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I invite everybody to follow us on Twitter as well as all of our other socials. Also, feel free to email us at facts@wolfSSL.com if you have any additional questions or comments. And now, before we start, I'd like to give a brief company overview. wolfSSL was founded in 2004 by Todd Auska and Larry Stefanik when we realized there wasn't an open source, dual licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial-style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 40 dedicated employees in 2020, most of which are engineers. This process, of course, is supported by a strong partner network that we're proud of, which includes ARM, STMicro, and of course, cURL, for example. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, FIPS certification and a FIPS ready offering, MQTT up to the version 5 specification, SSH version 2, TPM 2.0, and a secure bootloader known as wolfboot, as well as Java wrappers and JSSE support, and commercial support for cURL. All of these offerings are accompanied through maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'd like to turn it over to Daniel to talk about cURL.
Hello. So let me see where I am. This is me, Daniel Steinberg. I started the cURL project a long time ago, in 1998 actually, and I've been doing this for a long time, and I'm going to talk about how we test cURL and do things in the cURL project, but for sure we didn't do that from the beginning, but this has been a work in progress for a long time, and we've been gradually been improving things for a long time, and we're still continuing to do that. I work for wolfSSL these days, as mentioned before, and you know, cURL runs in some 10 billion installations around the world, give or take a little bit, but that's an estimate we have. So it means that it runs in virtually every device that is internet connected, and you have a lot of them yourself, everyone who's here, in cars, TVs, video games, operating systems, and phones, to mention a few of them. So testing cURL and getting everything done correctly is important, and having security is, of course, vital. So how do we write safe code? It's not a coincidence, of course, how we do safe code in anything. So we need to work on it, and we need to really care about it and make sure that we address the problems. And what I'm going to talk about today and mention how we test cURL is all things that you actually already know, and we all know that we should do them, and so on. So it's not going to be a lot of news or groundbreaking truths here that you will learn that you should do, but I'm going to tell you anyway what we do. And I think ideally all the things we do are actually things we all should do as well. So we try to do the tool and APIs in a safe way, and gradually over time I think we have managed to get the APIs and everything to do safe by default. So if you don't select what to do, curl will do it safely and securely. And of course we document everything, and then including internal details, so to help developers of curl and users of curl to use and develop curl safely. And of course we get rid of all the warnings when we build curl, which is, of course, I'll get back to that, but it's complicated. We comment the code a lot, where I am personally a believer in code comments, and I know that's a question sometimes if it's good or bad. We should use more assert in the code, and we of course release the code as open source, and we do that, have done it for a very long time. Of course that makes more users involved, more users of the code, more authors of the code, so quite a few eyeballs involved in the code that helps us find more problems and fix more issues. And we review all the code, which we say that all code shall get reviewed. It's not entirely true always, but that's at least our ambition. And we really strive to write the code easy to read and understand. And over time we've emphasized, and we've been stricter and stricter to stick to the same code style everywhere, which also means that we verify that quite a lot nowadays in the test suite. We have a commit message template that encourages conformity, or consistency I should say, even in commits, and reading commit history and understanding what commits are doing. And of course we make sure that this commit style and the templates are followed in commits. We do a lot of testing in curl. First, I just want to emphasize that we do unit test, system test, and integration tests, and we test part of the documentation, at least the parts of the documentation that we can actually test and verify, reference lists and look up things and make sure that things are consistent in different parts of the code versus documentation and so on. So we test here, and I say manual tests, I mean manual, the parts of the man pages are tested in the test suite. And of course we try to stick to this mantra that if we fix a bug, we add a test or two to make sure that the bug fix then gets verified, at least from now on going forward. We torment the code a lot. We use all the Valgrind address, all the sanitizers, in particular from Clang. We use a lot of static code analyzers. I will get into that as well. And of course we do fuzzing. All of that, all the time. So yes, for every commit and every PR, all the time we do all that. So the curl CI, pretty much what we run per commit and per pull request on GitHub, is right now approximately, I think we're at 84 or 85 different CI jobs. Most of them check out curl, build the entire thing with different configure options, build options, and then run the entire test suite. And we test code style, we make sure the indenting, we don't actually check everything, so you can actually cheat a little bit, but we at least make sure that most of the style and everything is correct in the proposed pull request, for example. And we do those thousands of tests in each build, and we test and run this on tens of platforms, I say here, because we of course want to do this on as many platforms as possible, but it's limited availability basically. So I think we're spending up around 25 hours of process time, CPU time per commit right now. So quite a lot of CI, and over time, as I said, as I started out, we have gradually increased the CI jobs in curl. So if you see this little graph here, back in 2014 we started the CI things on GitHub with a mere 2 jobs per commit, I think, and now at the right end of this graph you can see that we're up on, I think it's 84 in total right now, on these 5 different CI services. Split differently, we can see that we have CI jobs on the 4 primary platforms that we do CIs on, Linux, Mac, Windows, and FreeBSD. So we also then have a few sponsors. So most parts, or I should say that it says parts here of the CI runs on free tier. So we started out using all these 5 different CI systems on their free tiers, and then we have got sponsors that have bumped up our powers on some of them. So TeamViewer sponsors AppVeyor, both Travis and Azure are both sponsoring us themselves, and they have upped our CPU performance basically. So we're running on slightly more power than the free tier. That enables us to run more CI jobs in a shorter period of time. Otherwise, over time we have had really long times until all the CI jobs have completed, and thanks to these sponsors, they're actually completing now fairly quickly. And of course, we're also adding test cases over time, and a test case is a kind of a strange metric here, because test case for us could be a really simple small test, and it could be a really big complicated test. But I just wanted to visualize here that we're constantly adding test cases. So this is just the number of test cases we have in the curl code repository. There's one file for each test case, so it's easy to count. So as we can see, gradually improving or increasing over time. And funnily enough, the lines of code in the project is increasing, well, basically by the same sort of linear growth. Well, maybe not the exact same, but anyway, the size of the project is growing all the time. So we of course need to add more tests and do more testing, because we get more code to make sure that it's okay. And we want to make sure that writing test cases is easy, so that a new contributor can arrive in the project and be productive and start. That's an excellent way for a newbie actually in the project to write a test case and make sure that something is tested that wasn't tested before. So it's a single human-readable, well-documented format to write a test case, and it sets up what conditions and what it needs to run, what command line it runs, and a little bit, what server it needs, and some information about it, and what it's, the protocol it uses, what input and output for the particular command line, what's expected error code, and then that's it. So a single test case could be maybe as short as 50, 60 lines of plain text, or a complicated one could be several hundred lines, but still it's all in a single, a little bit resembling XML, but it's easy to read and fully documented. And of course we have a lot of existing test cases that you can just copy and paste from, or read and figure out how they work and get inspired by. So all these test cases then, they primarily use custom test servers. So we don't really use any real servers for testing. I mean, then when we test HTTP, for example, we don't run any actual, open source HTTP well-known server in there, but we have our own custom version that is actually as dumb as possible, because we want to have full control of the server so that we can test. The test case can basically tell the test server how to respond, what to respond and what to expect, and then we can tell the server to respond something really crazy, or send and receive whatever weird thing we want to do when we test curl, because we of course want to make sure that we can do the negative tests properly as well. And it also makes the test server smaller and simpler, and it makes it easier for us to actually be able to port the test suite across all the platforms, right? Because we want to be able to run the test suite on all the platforms curl can run on, which isn't really true, because it doesn't, because curl runs on a lot more platforms than the test suite can run on. But still, at least on as many of the platforms as possible. The TLS parts we do in the test servers, we front the TLS side with S-tunnel. And starting fairly recently, we nowadays run the test servers on random port numbers, with a little thing I just wanted to mention, because over time it has turned out that it's actually pretty convenient when the tests run on whatever is available on your machine and not on a fixed port number, because we never know exactly what's running before on the server, and you can now run the curl test suite twice in parallel, right, in 2 different shells, because they use random port numbers. And how do we do this? The CI and the testing. So we hammer on the code, or that's the kind of the visual little symbol I want to use that. So we use valgrind, of course, valgrind, I don't remember exactly how do they pronounce it. I think they say Valgrind. And we of course do builds with Clang and all the sanitizers with Clang, which is a pretty good way to make sure that we're doing things right memory-wise and address-wise. And we build with Clang tidy, and we do our own torture tests, which I will explain in a second. And those are sort of, they instrument the code and they make sure that they help us make sure that we don't leak memory and we don't violate these rules. And then we have the code inspectors, right? The static code analyzers. We use the scan build one, which is from Clang. We use LGTM Codacy for code analyzing. We are part of the new GitHub beta program that runs codecURL on the code. And we are also doing part of another beta program which comes from Microsoft called Monocle AI, which is an AI-powered code analyzer. There's another Deep Code AI, which is also another code analyzer, and we're running Coverty. So we have 7 code analyzers scanning the curl code. Most of them in the CI. Some of them we just run regularly. And we make sure that we always fix all the effects they found. So we, as I mentioned before, we use these 5 free available CI services. And one reason we use all the 5 is, of course, to maximize the amount of free CPU we can get for CI services, so that we can spread out the load on many different services so that they can complete faster. And we have some build bots too for those that aren't cloud services, but voluntary run build bots. And when all of this runs fine, we also add the fuzzers. So we're part of the OSS Fuzz program from Google. They run fuzzing on curl nonstop. And we're also doing the CI Fuzz part, which is also as a service provided by OSS Fuzz, which allows us to fuzz for a limited time, fuzz each pull request and commit using OSS Fuzz to make sort of check that is it anything obviously bad in this. I mean, it runs the fuzzer for a limited number of time. I think it's 40 minutes now. So there's a big sort of, it doesn't at all catch everything, but if there's anything obviously immediately super bad, it will catch it. Otherwise, the OSS Fuzz thing will do it later. And I mentioned the torture tests we do. So torture tests in curl is a thing. I mean, the name torture test is I think it's my name I came up with a long time ago. It might not be the best, but that's what we refer it as in the project. So it's basically error injection. So when we build curl to do torture tests, we build it with debug option, and we add wrapper functions for each, not each, but a lot of fallible functions, right? malloc and strudup and fopen and a socket function, a lot of functions that are allocating resources and that can fail. So we have wrapper functions for all of them, and each of those wrapper functions, they can either do what it's supposed to do, or it can return a failure. So when we run the torture test, we first run the standard test case as it's supposed to run once, and we count how many of these fallible functions we invoke. Basically, there are usually around maybe 70 to 300 function calls, and then we rerun that same test case 70 times or up to 300 times, and for each iteration we make another one of those one of those functions fail. So basically we make sure that each of those fallible functions, when they fail, that we handle the failure correctly. There should never be a crash, there should never be a memory leak. It's actually a really good way to make sure that all the error paths are tested, and that we never misbehave when an error actually occurs from one of these functions that may actually return error even in the real world, which I think it's a fair thing to require from a library, that we can handle failures basically at any point. And then we run through this for all tests. And of course, this takes forever when we have a few thousand tests and each test has to run a few hundred times each. It takes a really long time. But it's a very good test, and it's helps us to make the library solid. And I mentioned pretty early on that we have a strict about our source code policy, what we do when we write code. So we make sure that we fix all warnings, and this is way easier said than done. We don't actually fix all warnings, but this is our ambition, to fix all warnings. Some warnings are just not possible to fix, because fixing them on one platform can generate them on another, especially on the really early platforms and some of the more legacy ones. So we're trying hard, but it's not always possible. We never leave any defects found by any static code analyzer. We always build everything with the strictest and most picky compiler options, so that they would find even just suspected minor mistakes. We fix them and make sure that they don't warn anything. And we have virtually as many tests as possible. So we add more and more tests all the time to make sure that we are testing more and more of cURL, of course. I think right now we have code coverage is a complicated question, especially in a project like cURL, because we have so much conditional code and we run on so many different build combinations and different platforms, but we're around 80 to 90% of the code is covered in test cases. And we fix all security issues as soon as possible. Misspelled on this slide, but I'm going to come back to that in a little while. So as I mentioned, we have I call them in this title 1 million build combos, which I think is an underestimate, because I think we can do even more than 1 million build combinations. We basically have a lot of ways to build cURL, because you can pretty much disable all protocols and a lot of features, and we have a lot of third-party dependencies. So there are probably billions of build combinations. So it's just not possible to test them all. So we test the most common ones, and we test on the most common platforms. And of course, we test on several different CPU architectures. So thanks to that, we cover most of the code and all the important combinations. And well, there are white spots left that we don't test. And they're not easily detected that they're not tested, but we try. It's really, so we try to handle that by review. And of course, we have users that then run into problems sometimes and file bug reports. But in general, we have enough overlap and so that all code is tested somewhere. So it's usually it's enough with having enough of all that to cover most of the things. But of course, the security of cURL is the sum of all components that you use when you build cURL, and you build cURL usually with a lot of different third-party dependencies, like maybe up to 32 different ones, as I mentioned. On this little slide, you can see third-party dependencies as the little boxes in green. And these red brownish boxes are just different components in cURL. You can, a bunch of them you can enable disable. And then of the green ones, you can enable disable a lot of them. Some of them are mutually exclusive. You can't use all of them at the same time. So you can't really build all of these 32 at once, but in a lot of different combinations. So I'm just suggesting that when you go with cURL, you will also pick a bunch of these ones and use them in your application and rely on their security and testing as well. So you really need to pick one, or the ones you think are good and trustworthy in your products, just to then show you that I work for wolfSSL, and in wolfSSL we not only cURL are we testing a lot, we are testing everything at wolfSSL a lot. So the TLS library wolfSSL, of course, just to make an example here, is that it is tested and fuzz tested a lot. So it's being fuzzed by 6 different fuzzers and a lot of different security testings. Trying to emphasize here that yes, that's one way to do it. Go with the library you think is trustworthy and tested and verified. One way for us to make sure that we haven't messed up completely or well, maybe the other way around. They tell us that we have messed up. But okay, we have the curl bug bounty introduced a little over a year ago, April 2019, I think. We actually dabbled a little bit back and forth. We tried to get it going before that, but this program is started in April 2019, and I think it's been a success so far. We run it together with HackerOne. So this is the URL you can go to and read about it. And if you have a suspected or known security vulnerability, go there and tell us about it. And we will give you money for it if we end up considering a security problem, of course. So we pay rewards for security bugs using donated money. We don't have any other money than donated money in the curl project. We pay rewards up to 12,000 USD right now in case you file a critical flaw that matches the criteria here. And I should mention that nobody has ever found and reported a critical flaw in curl, so I think the bar is pretty high to get that amount of money. But we have paid out 2,300 USD so far in the program in these 14 months that it has existed. So we are at least paying money, and we're trying to increase the bounty amounts over time because it seems to work, this thing. We're getting fewer reports and we're getting donations enough to continue this project. So just to show you a little graph of the accumulated curl bug bounty payouts. So we didn't pay anything for a very long time because we didn't have any bug bounty program. And then we started the bug bounty program, and now we're paying more and more money in bug bounties. So hopefully, of course, we don't have to pay much more because there won't be any more security problems. But I don't think that is realistic to expect. So of course, this is a chance for you to get involved. Whatever you do, if you're researching for, security, or you're using curl at a corporation or company or whatever, get involved, find something, report something. And of course, you can run your own fuzzers and testing and whatever. And as long as you report security problems and we agree that it is a security problem, it's a bug bounty worthy thing to consider. And there's one more thing curl has that, that the ordinary HTTP library of your choice maybe doesn't have, and that is me. I work full-time on curl every day, all day, so I spend my 40, 50 or 60 hours a week improving curl and curl security, of course, because curl security and safety is high on my agenda. So I'm, of course, employed by wolfSSL, and we make this possible. So that's a good thing. I don't want to, I'm not meaning that I'm in particular is particularly brilliant, but at least I'm spending a lot of time and I'm helping coordinate everything and get fixes and work on stuff to make sure that it gets better. But no matter how hard we try, and we do try quite a lot, and as you've seen, we do a lot of testing, we do a lot of making sure things are okay, but things will still fail at times, right? No matter how hard we try, we fail at times because we're continuously developing and doing new things and trying new things, and we work on a bazillion platforms. So every now and then mistakes will happen. The bobby car will end up upside down. And then we, of course, we act immediately. So we own the problem, we fix it, we announce it in the next release, we tell everyone about it, and we try to learn from it and make sure that we don't do the same mistake again. Hopefully, this is what we want to do, and this is what we try really hard to do, to take a chance that when someone has reported a security problem and we have fixed it, that we analyze what happened, how did this end up in our code, and what do we do to make sure that it doesn't happen again. It's also easier said than done, but we're working on it. And of course, I mean, this is an open source project. You can join in and help us make sure that we learn from things, or tell us your good advice on what we could do to improve things that we haven't done yet. This is an ever-going project, right? So there's always more things to do and always areas to improve and make sure that we enhance. Okay, so we do a lot of this. We do write code, we test code, we run all this. Does it work? Does it actually improve curl over time? I said 10 billion installations, and I think I don't think that's an exaggeration. It depends on actually how you count installations. But for example, most mobile phones have several installations of curl, so I would actually, if you count like that, it would probably end up more than 10 billion. But anyway, I don't think it's a proof that it works just because we have 10 billion installations, because I think a lot of users, they will install it even if it's not that good. But I'm looking at some other metrics instead to judge if this method of ours work. And I would say that we have a decreasing number of CVEs over time. I'll show you in a second. And I think that is a hint that maybe we're going in the right direction, because we have more researchers, we have more code than ever. So maybe if we had not improved, I don't think we would have decreased the number of CVEs. We would have gone the other way instead. And we have a decreasing number of OSS fuzz reports over time, which means that we've actually, glued things together and tightened the worst problems and made sure that with the most obvious problems that the fuzzers could find 2-3 years ago, they're gone now, and they don't come back, because nowadays we fuzz nonstop all the time, so they find the problems as soon as we try to land them, so we get time to fix them before they actually end up in the release. And we are able to increase the bounty rewards, or the amounts that we pay out in the bounty rewards, which is also a sign that we're not actually getting that many bug bounty claims, so that we can actually afford to increase the bounties. So good signs. So what I mentioned about this CVEs reported per year. So this is a little slide showing the year of the I think this is the year we announced the CVEs, published them, and we published 2 so far this year in 2020. So you can see that we're actually way ahead if we keep this rate, which I really, really hope we do, or at least not go any faster. It will be a year that will end up better than 2013, and as you can see, that's really, really reduced the number of CVs that we have had over the last 6 years or so. The 2016 is a bit of an exception in this graph, but that's because we had a security audit. So we have a particular company look at the code, so that resulted, I think, in 7 or 8 extra CVs, because we had that extra concerted effort that year. Still, I think it looks better. I mean, the trend is certainly going in the right direction here. So basically, just want to go back and emphasize what we are doing, our concept in curl. It is basically that we try to make the code as clean and readable as possible. We do that, and we help out to get the logic mistakes fixed by reviewing everything. So all codes is reviewed. We test all the stuff as much as possible, and then with Torment, we run all the tools that we can get our hands on. A lot of code analyzers, a lot of torture testing, a lot of hammering and everything. And then we act when we find mistakes, and we have the bug bounty program that makes this sort of sums it up what we do regarding the curl and testing. And that is basically what I wanted to tell you about. And I'm sure I've left something juicy out of here and forgot about something, but I'm very keen on answering your questions for whatever I forgot to mention. Thank you. So
okay.
I could just answer the first question. So someone asked me what library or toolkit curl uses for unit tests, and curl is not using any library or toolkit. It uses its own unit test toolkit pretty much. So it's all written custom for us. But unit testing in C is pretty simple. It's just a set of macros and functions, and it's pretty easygoing, straightforward.
There's a question here that's asking how much effort was spent to set up and configure tools such as LGTM or codecURL, Coverity, etc.
Oh, most of them are really easy to set up, since that's the kind of beauty with the modern way of doing things in GitHub, and so that a lot of these services there are very GitHub friendly and do everything in the cloud. So you basically just have to add them as an app in your GitHub repo, and they are pretty much going by themselves. And then of course you have to go through and mark a few of them as ignore this false positive and so on. But most of them are easy to set up and run with. Coverity is possibly slightly more work, but I don't think setting them up is the bigger part of the work with code analyzers. Setting them up is pretty easy. I think it's much more work to actually address the problems they find, at least initially, and then it gets easier over time. So adding a new code analyzer now, I added this deep code AI the other day. It was just clickety click, and it was up and running, and it told me a bunch of false positives. So yeah, now most of them are really easy.
Does the project have some sort of systematic way to check for performance regressions, like increased memory usage or CPU cycles?
No, it doesn't, and that's one of the things we've discussed and we've wanted to do, but we haven't. So I personally have a few scripts that I run every once in a while just to count a few things. I usually count like memory usage and number of mallocs in a very standard use case that I know that I've run this standard use case every once in a while for the last few years. So I know roughly what it should look like, but we don't have that in a systematic way, and we don't have that set up, so we won't discover it that easily, which is it's a sort of I want that, but we don't have it. So that's an excellent area to join in and help us with.
Of all of the tools you mentioned, the pedantic compiler, statistic analyzer, Valgrind, etc., which do you think is the most effective at catching potential bugs?
Oh, I think it's they're all helpful. I think in general. So I think it depends on, since we get a lot of contributions from a lot of people also. So I think some users will get more help out of some of these complaints or warnings and messages and everything. So I think it depends. I think it's hard to say which one of them. I think they're all pieces of the big puzzle. So if we would remove some of them, we would get worse end result. But so it's hard to say. For me, it's also not I don't really have to value which one of them that are best. And of course, when I've talked about this before to people and I say we do all of this, people get a little scared. Oh, do you really have to do all of this when you run your own program or project? But that's not really the question, right? It's the more checks we can add, the better it is, right? As long as we add good checks, all new checks are just good as long as we have time to do them. So I think it's really good. They're all different. So what I'm mostly scared of these days when I add a new test is basically that they're all just testing the same things anyway. So when I add a new static code analyzer like the other day, they will just run the same underlying logic anyway, so they won't find anything new.
Comment on C and choice of C90.
Yeah, talking about security and testing for security, of course, you could argue then, okay, so we're using C here, 10 billion installations. So, and of course, C is not a safe language, and C90 is one of the most conservative ways of going with C, of course. But first, we're using C because that's the most portable way we can go. That's one reason for curl success. We're everywhere on I think we counted 72 different operating systems, and you don't do that with any other language. And then why C90? That's also because of that, because we stuck with C90 for a very long time because of basically legacy systems and the availability of C90 compilers on them, but not so often more modern compilers. And I mean, even Microsoft didn't even have C99 until recently. So it has been a reason to just stick to the old traditional thing, and then curl can work on more platforms. Nowadays, we could have a debate if we should really stick to C90 or if we should go to C99 one day, and maybe we will. I don't know. Whenever I bring up that question in the project, there will be 2 or 3 people who will pop up and say that they don't have C99 compilers. So that's pretty much where we are.
Okay, having a lot of platforms to test in multiple CI, false positives must be a hard problem to tackle. How exactly do you handle that?
Yes, false positives is really, really complicated and hard when it comes to CI. So. Yes, it's really a challenge. As I said, we have 84 jobs or something in the CI set now. So basically nowadays, at least that with the situation we have right now and for the last few months or so, is that more or less there's always 1 or 3 jobs that fail due to some circumstances that we're not in control of. So we rarely have all 84 tests go green. It's more of a rare occasion than standard, which is unfortunate, and I don't like it, but it's really hard. So yeah, we try to make sure that we can, mark tests as flaky on platforms and don't run it on platforms that can't run the test. And if they're not reliable, don't run them there and don't check for them there. But it's more complicated than that. So yes, maintaining a test infrastructure like this on so many platforms, on so many CIs, it's a lot of work, and a lot of us need to keep on working to make sure that this gets even better going forward.
Does curl do tests with old wolfSSL versions, example 3.6, to test specific behaviors?
That's a very specific question, right? wolfSSL version 3.6, I don't retest that, but in general, we do tests with a variety of different configurations, I should say. And which set of configurations, that will vary over time, and it'll be mostly a question if we have reason to believe that we need to test that. If is that a problematic combination? Do we get a lot of bug reports on that combination or stuff like that? Or is it a common combination perhaps in a distro or some users? Then we add that to the CI and test for that specifically. I don't think I'm personally not aware of any particular issues or behavior problems with wolfSSL version 3.6. So we don't do that in the CI.
And that was our last question. Thank you so much to Daniel for a wonderful webinar, and thank you everybody for attending. I had a wonderful time. Just to remind everybody, this webinar will also be recorded and made available on our YouTube channel following the presentation. Look out for a follow-up email from us with a link to the YouTube channel, or to the video. And I invite everybody to follow us on Twitter at wolfSSL as well. And if you have any additional questions about curl or any other wolfSSL product or anything else, please contact us at facts@wolfSSL.com. And thank you so much for attending. I hope everybody has a fantastic day.
Thank you. Bye.
Bye.